Solving by factoring. This is something that we saw in Algebra 1, and we are going to go through it quickly, but it's important that we review this concept because it's going to be important to us as we develop working with what are called quadratic functions. So first, the zero product rule. The zero product rule says that if we're multiplying two things together, one of them has to be zero. So if we can factor a problem, we can find the answer by setting each factor equal to 0. So a quick review of our factoring. First, really important that our equation must equal 0 before we do anything else. Second, don't forget to look for the GCF first. One does not start factoring without looking for that GCF first. And from there, we had lots of strategies we used. If we had a trinomial, we did a guess and check. If we had a difference of squares, we know that's a plus b times a minus b. So lots of different factoring strategies we can use. But first, make sure the equation equals 0. And don't forget to factor that GCF first. So let's try a few examples. Here, this first example, 9x squared minus 16 equals 0. It's a quadratic function because it's got that x squared in it. And we're going to attempt to solve for x. It's already equal to 0, which is nice. So now we can try and factor it. And what you might notice is with two terms, we're going to try and use a difference of squares. In fact, we can take the square root of both parts. The square root of 9x squared is 3x, and the square root of 16 is 4. And we recognize the difference of squares. We're going to add and subtract those. 3x plus 4 and 3x minus 4 equals 0. And now it is completely factored. Once it's factored, we know we can set each factor equal to 0. 3x plus 4 equals 0, and 3x minus 4 equals 0. And that gives us two linear equations that we can solve. First, by subtracting 4, giving us 3x equals negative 4. Then finally, dividing both sides by 3, and x is equal to the fraction negative 4/3. Same thing on the other side. We add 4 to both sides to get 3x equals positive 4, and divide both sides by 3 to get x is equal to the fraction positive 4/3. So there's two possible solutions to 9x squared minus 16 equals 0. Negative 4/3 and positive 4/3. The second equation is a little bit more involved, but the same idea here. 2x cubed plus 5x squared minus 12x equals 0. It already equals 0. Always check for that first. Next thing we check is there a greatest common factor we can pull out? And sure enough, in this case, there is. Everybody's got an x, so we'll pull out an x, leaving us with 2x squared plus 5x minus 12 equals 0. From here, we're going to try and factor the remaining trinomial using that guess and check method. 2x squared is 2x times x. 12 can be lots of things, maybe 4 and 3. We'll put 3 and 4 because the 4 can't be paired with the 2. That would give it a GCF, and we can't have GCFs. If the 4 is positive and the 3 is negative, on the outside, you'll see 8 minus 3 is positive 5. That works in the middle. We have factored our polynomial. And once it's factored, we can set each factor equal to 0. Don't forget about the GCF. He's a factor 2. X equals 0. 2x minus 3 equals 0. And x plus 4 equals 0. From here, we can solve each of these really quick. X equals 0 is already solved for us. The second equation, 2x minus 3, we'll add 3 to both sides, giving us 2x equals 3. Divide by 2, and x equals 3 halves. And the last equation, we'll subtract 4, and x equals negative 4. So we have three solutions for x: 0, 3 halves, and negative 4. Don't forget to factor out the GCF. Two more brief examples for you. These, you'll notice, do not equal 0, so we need to do a little bit of work. If we see x squared, we can't directly start solving for the x. So we need to first make it equal to 0, then factor, then set each factor equal to 0. So to make the equation equal to 0, I'm going to subtract 25 from both sides. That gives us 4x squared minus 25 equals 0. And now you might notice we have a difference of squares. The square root of 4x squared is 2x. The square root of 25 is 5. So 2x plus 5, 2x minus 5. And now we're factored. So we set each factor equal to 0. 2x plus 5 equals 0. 2x minus 5 equals 0. And solve these two remaining expressions. Subtract 5 from both sides. 2x equals negative 5. Divide by 2. And x is equal to negative 5 halves. Similar on the other equation. Add 5 to both sides. 2x equals 5. Divide both sides by 2. Sorry, moving too fast. And then we get the positive 5 halves. Two solutions for x, negative 5 halves and positive 5 halves. One last example. Again, you'll notice it does not equal 0, so we need to subtract the x from both sides to make it equal to 0. No like terms, so we have x squared minus x minus 12 equals 0. And then we can try and factor. X squared is x times x. 12 is 4 times 3, and if the 4 is negative and the 3 is positive, it'll give us that negative 1x in the middle like we want. So first we make it equal to 0, then we factor, then we set each factor equal to 0. X minus 4 equals 0, and x plus 3 equals 0. And from there, we solve. Both of these are really quick. We'll add 4 to both sides. So x is equal to 4. And we'll subtract 3 from both sides to get our other answer of negative 3. So two answers for x, 4 and negative 3. This was a really fast review of solving by factoring. In Algebra 1, we spent a whole chapter on factoring and how to solve by factoring. And so if you want more detail, you can go back to your Algebra 1 notes and look at all of that. But let's take a look at the homework assignment from here. Ask your instructor if you have any questions, and let's practice solving quadratics by factoring. And then we can take a look later at how we can solve quadratics that do not factor.